Python's Pandas library. Pandas is used to process tabular data. What do we mean by tabular data? Data that are presented as rows and columns. The columns represent variables or attributes or whatever you would like to call these columns, and the rows are records or tuples or examples. Again, Pandas is a Python data analysis library where data is stored in DataFrames, like R or Spark if you have used these systems. Pandas can read and parse CSV and JSON easily, but XML is a little bit more difficult, perhaps due to the XML structure. More on data frames. Data frames are a data structure used for storing tabular data, used in R and Pandas. The two-dimensional labeled data structure organized into rows and columns. And the meaning of labeled data structure is the columns. Each column should have a header or a name. Each row corresponds to one example, or sometimes the row is called record or entry. Each column contains data for a specific variable, if it's a name, age, etc. And you can access a row, column, cell, subset using the Pandas API. For the following few slides, we will go over some of the basic operations in Pandas, such as reading a CSV file, performing basic operations like slicing, compute some basic summaries as minimum, maximum, and so on. So in order to use Pandas, we need to import Pandas, and read CSV will read the file for us. And if you type data or print data, you're going to see the dataset. And in this dataset, Oscar age female, it consists of the names of the actresses who won an Oscar by year and age and which movie. So in order to get the number of rows, we type plain data. If we want to get the name of the columns, data.columns. And if we are interested on the data of a particular column, then we do data.age. Head and tail are similar to the Unix commands, where we want a number of rows from the top of the data frame or a number of rows from the bottom. And of course, wherever we go in Python, there should be some slicing, and data frames are nothing but lists of lists, so we can have the same syntax. So if we want to slice the 3 rows, we can do data column 3. And if we want to slice based on the rows and columns, we use iloc. So in this example, we get 3 and 4 rows with year, age, and name columns. And to summarize the data to get some computations about the numeric columns, we use described. We get count, mean, standard deviation, and so on. But if we are interested in a particular mean or sum for a particular column, then we have to write it specifically. And it's common that we want to add a column to our data. In order to do so, we do data and the name of the column equal an initial value. And this initial value can be something we compute from the data itself, like year plus 1 in this example. And also sometimes we would like to add a row to the dataset. So we can create this row. So the row consists of a series object, which is the data and the names of the columns. So we constructed using the series, which takes the data and the name of the columns. And in a little bit, we will do a demo and see what is a series looks like. And then we append it to the data frame. And notice here there's a parameter or argument called ignore index equal true. Well, this has to do with the indexing of the data frame. And if Python to create this index for the data that it appends, it's going to be very expensive. So this syntax forces it to ignore the indexing. And then here we show the tail. I already created a notebook with the examples from the slides. So here we read the data from CSV and I can see all the rows. There are 89 and 5 columns. I printed the number of rows and displayed the name of the columns. Head of the name attribute will give the 5 names, first 5 names, and ilog gives this slice. Describe shows summaries, and this is example where we added a new row. So first we created a list, then we obtained the name of the columns and created a series and printed the series, and this is how this series look like. Index 90, year 2017, age, and so on. And we can see that the row got appended at the end and it returns a new data frame. And in this example, we show when we added a column and used the value of another column to give it an initial value. Subsetting data means which parts of the data we want to display. Filters or filtering, we want to display the data if a certain condition is met. So we only want the rows where data.year is greater than 2000. So this is a filter. Another filter that we want greater than 2000 and age less than 30. Selecting columns, you can specify the column name, data, then in a sublist you say age and movie, or you can use the filter operation and say which column names that you want to display. We have seen this syntax before, how to add a column based on existing data. So this one is called is odd year, and if year modulo 2 equal 1, then equals, then this will be the true and false, the value of this Boolean expression. Then data.head will display the 5 rows. Selecting a subset of rows based on a Boolean condition, we can construct a Boolean condition based on the values of these attributes or these column names. If data is odd year, which is the Boolean value, and age equal 29, or data.age equal 42, so we want those with age 29 and 42, and the year is odd, and we get some output. Also, we can make this filter a regular expression. So in this regular expression, we want all the rows with name that starts with Kath. We get Catherine and Kathy. Also, we can use Pandas sample to get a random sample from this dataset. Very often we receive a dataset with missing values for particular cells. And we need to devise ways to deal with the situation. Do we have a best guess to fill missing values, or we want to drop these rows? Is what we're going to see next. In this example, we will look at grades.csv, which has student names, their social, and test 1, test 2, test 3. So if we want to know if there are missing data, then we can just look in the eye and look for if there's something empty like NaN. This is like not an efficient way. We need to look at something called info. So info will tell us how many non-null value, which means, so if we know that we have here 16 row and here we have 15 non-null or 13, then we know that there is something missing in these columns, then we have to fix it. The first approach for dealing with missing values is just dropping these records. We no longer have them, but we can't drop students, right? Another approach would be filling these NAs with zeros or maybe filling these values with something else like the average. And there is really no right way to clean data, and there are a lot of work about what is a best way to fill these missing data, because we want to be able to do some analysis on these datasets with these missing data.
The last topic in this lecture is aggregating data, which means we want to summarize it using an aggregate functions. Meaning, we want to compute a function like the minimum or the maximum or the sum for a column, or maybe we want to create groups and then compute aggregate computations on these groups. That's what we mean by GroupBy. We want to create groups, then for each group, we want to perform a computation. So let me give you a heads up about what is GroupBy. Suppose we have this data set. Let's say that the data set is about salespersons who sell stuff. Let's say Abby,
she made like 100 in sales in May. Then Alex made 50 in Jan, and also Alex made 20 in February. Then there is Jane, made 40 in October, and Jane made 20 in September. Then Abby again made 200 in August, and another 100 in September. Yeah, so what I want you to see like in this column, the column of the names, the people do repeat because they did some sales on various months. So GroupBy wants to know that we want to group those names. So we have Abby. There are 3 Abbies. So we have 1 Abby. And we have Alex. And we have Jane. See? And each one of them represents a group, because Abby has a record for May, August, and September. Alex has January and February. So we need first to group the data. So for each group, we want to compute an aggregate function, like, let's say, maximum. What is the maximum sales for this person? So for Abby will be 200. For Alex will be 50. And for Jane will be 40. So this is what we call the group by. We grouped by the name, and after that we computed the maximum for each group. Let's take a look at this example. So here in the grades.csv, we have final grades of A, B, C. So to make life easier, first we wanted to drop the pluses and minuses, so we only get a letter grade. And for each letter grade, we want to know what is the mean. So for A, maybe we have 5 students got A, 10 students got B, 3 students got C, 4 D, 2 F. So for each group, we will need to get the letter. And for those people who get this letter, we want to compute the mean. We dropped the pluses and minuses just so we get smaller data set. And then we get unique values. data2.grade.unique, and then we want to do this aggregate operation. So for grade data and data2.groupBy of the grade, we want to print that grade and the mean of this grade. Let's go and try to make sense of this in our notebook. So let me copy this here. And first, so here we find the unique values. So let's cut this a little bit and run this. So here we just did some cleaning, and then data2.grade.unique. So grade.unique would be, those letters. And let me add for grade data and data2.groupBy based on the grade. Then I want to print the grade and the mean of this grade and run it. And that's how it's got computed. It's like the Abby and Alex and John. So there are several rows for each unique name. We want to sum or compute the mean or maximum or some aggregate value, a group level operation. Let's see what's in here. I can also aggregate directly over a group object, data2.groupBy group, and then you specify which operation, which is the sum. Here you say groups.final, which is the attribute.aggregate. So what's the name of the function, which is here min and max. So GroupBy is not a straightforward operation. So I suggest that you just take a look at this data again and try to work out an example and really see how these values got computed. So Lambda functions are functions without names. We use them where the function is only going to be used once. And an important application for the apply operation that you need to pass a function to it to tell it how to transform the data. So the term lambda makes the temporary function, then x is the parameter, and then this is the body. And here's an example how we use lambda with map, and also we look at apply. But let's see it in action. So we're here, we created a lambda function called roundGrade. We take a grade as a parameter, divide it by 10, then multiply it by 10. And we want to use this lambda function to map the values of test 1. So if you remember what was on test 1, so these were the values of test 1, then we need to map them using this function, and then we get the rounded value. See here we have 40, 41, 41, 42, and we got these values. And this code apply function to more than one column of data. So here is one column, here's another column, and we want to apply on these columns the sum. So we compute the sum on these columns. Standardize final grade by subtracting mean and dividing by standard deviation. So just we find the average and standard deviation and print them here. Then we create a lambda function on the fly and pass it to the map, and this does what it says here. Subtract average final from x and divide it by the final, standard deviation final, and then map the value of the final to this value. So this is the last item in this lecture, how to write data. So how to go from DataFrame to a CSV. So to CSV, then the file name, and then whatever you want to use as a separator. I conclude this lecture and I wish you good luck.